Hello students, in this class I am going to teach you a new design called the experimental design in social research. In the previous classes we have been studying about few more designs, namely the descriptive design, the diagnostic design and the exploratory design. In the case of the descriptive design, it is just explaining an event or a person or a group of people. But in the case of diagnostic design, we said that the solution for an issue has to be sought out. In the next design, namely the exploratory design, we said that we have to find out the causal relationship between different variables. The experimental design is also meant for finding out the causal relationship, but the experiment is conducted in a different manner. Normally when we talk about experiments, we think that experiments are unique only to physical sciences and biological sciences, but in social sciences also the scientists try to use experiments in order to make research more scientific. So, also in sociology we have conducted experimental research with the help of the experimental design. That is what I am going to explain to you in this class. Experimental designs are primarily concerned with testing causal relationships. Originally, Comte designed and applied this design to social research, but his experiments were based on controlling natural forces. The modern experiments in social sciences are well developed. Experiments in natural sciences are very common. In social sciences, experiments are conducted in psychology, education, social work and sociology. The term experiment refers to that part of research in which some variables are controlled while others are manipulated and their effects on controlled variables are observed. In experimental design, the conditions of occurrence are important to be considered. The conditions could be differentiated as necessary condition, sufficient condition, contributory condition, contingent condition and alternative condition. Studies designed to test hypothesis of a causal relationship are termed as experimental design. In experimental design, the research asserts that a particular occurrence, say X, will determine the occurrence of another event, that is, X is the cause of Y. It is also possible that whenever X occurs, there is the likelihood of Y to occur. This is called concomitant effect. In experiments, the time factor should be taken note of keenly, that is, Y follows X, not X follows Y. In physical world, the direction of causation is possible, like the boy hit the bottle with the rod and the bottle broke. Here, the hitting with the rod is the cause for the breakage of the bottle, but in social events, contributory or partial causation is recognized. The cause of an event may be indirect or probable. To establish the causal relationship between two variables in social sciences is done with the help of experimental design. In experiments, we identify two different variables. One is dependent variable, in which the changes are results of the influence of the independent variable or variables. The independent variable is the one that is manipulated or treated in a study to see what effect it will have on those variables proposed as being dependent on it. For example, sex is an independent variable and education is a dependent variable. Experiments are studies in which the researcher has control over independent variable and the assignment of subjects to different conditions. The ideal experiment is conducted in a laboratory in which the effects of the independent variables are assessed, while other possible effects are ruled out. However, experiments cannot be conducted in real life situation, but if the researcher has enough control over the environment, it may be tried. There are several steps in conducting the experimental designs, which we will see now. Start with an appropriate hypothesis. Decide on an experimental design that will suit the proposed hypothesis considering its limitations. Next, you have to decide how to introduce the situation that induce the independent variable. Then develop a reliable measure of independent variables. Set up an experimental setting and conduct a pilot study. Locate appropriate subjects. Now, you have to divide them into groups. Next, introduce the experimental variable and monitor both groups. Gather data for post-experimental analysis. But before doing all these things, you have to give a brief explanation to the subjects about the reason for the experiment. Then finally, examine data collected and make comparison between different groups and analyze the results. Statistical tools may be used to prove if the hypothesis is supported or refuted. To conduct an experiment, we should have two groups, a control group and an experimental group. The control group provides essential protection against the possibility of factors other than experimental treatment that could influence the dependent variable. The experimental group is the one on which the experimental variable is applied. That is, experimental group is the one on which the experimental variable is applied, while the control group is the one on which we are not going to apply the experimental variable which we are trying to establish. Yes, students, I said that we need two groups to conduct an experiment. How are we going to form these two groups? On what basis we are going to group them? There are two ways by which we can do it. One is randomization and the other one is matching. What is randomization? Randomization involves random assignment of subjects to these two groups. The assignment procedure might have each subject the same chance of being assigned to any one of the two groups. This could be done just by flipping a coin or giving random number. The members of the control and experimental groups are assigned at random so that each subject is given equal chance of being assigned to the group. The choosing may be done either by flipping of a coin for head or tail procedure. This does not mean that these two groups will be exactly alike, but that whatever difference do exist between them prior to exposure to the experiment variable may be due to chance. That is why we say this is randomization. We are not trying to match them with all their background characteristic features. But in the case of next procedure, which we call as matching, it is quite different. Now we will see what we do under matching. Matching of members to each group, that is the control group and experimental group, is done by balancing of each member with the counterpart to another group. That is, certain factors like age, sex, intelligence, education and other such factors are perfectly matched with members of each group. Matching increases the sensitivity of the experiment, but matching of groups is a difficult work because of certain reasons. If matching has to be done perfect, then a large number of cases are to be selected in order to get adequate pair. There may be cases for which no matching is possible. Another difficulty is to know which factors are more significant to be matched. And finally, there are a few factors like attitude for which no matching can be perfectly made. In the case of matching, certain background factors of the subjects with same qualities and features are taken into account. Care is taken to match them perfect. With this part, we understand how we divide the subjects into two groups, and now we need to start conducting the experiment. There are numerous types of experimental designs to suit the nature of the study. The two most significant and basic forms are after only design and before after design. The first one is after only design, which I am going to explain to you now. Individual subjects are randomized to make two groups. These two groups are not measured with respect to the dependent variable before the exposure to the experimental variable. The experimental group is exposed to the experimental variable now. The control group is not exposed to it. Both the groups are measured after the experimental variable is introduced on the experimental group only. The variation found or not found on the experimental group will determine the relationship between the two variables, either as positive or as negative. For after only experiment, I will give you an example. For instance, a researcher wants to study the influence of sound in the performance of the students. Here, he introduces noise while the students are performing their examination. Prior to this, he has divided the group into two as control group and experimental group. On the experimental group, he is going to apply the sound or the noise. When the experimental period is over, the researcher is trying to measure their performance level, that is the performance level of the subjects who come under both the experimental group and the control group. Now, he will try to prove whether the effect of sound or noise has a positive or negative influence on the performance of the subjects. Here, the performance level of the subjects is measured only after the experiment. Therefore, the researcher cannot establish that the performance level either increased or decreased because of the noise only. The reason is that he has not measured the performance level of the subjects prior to the experiment. So, this type of experiment has its own drawbacks. In order to overcome this defect, researchers have introduced another type of research design. This is before after experimental design. Before after experimental design. In before after experimental design, randomization is done as explained earlier. In this design, both the control and the experimental groups are measured before the exposure of the experimental group to the experimental variable. Then the variable is introduced. The measurement is done after the experiment for both the groups after the introduction of the experimental variable. This ensures the reliability of the experiment. For before after experiment, I will give you an example. Suppose we want to study the attitude of male adults on the status of women or abuse of women. When we start the experiment, we divide the groups into two, as control group and experimental group. Before starting the experiment, we supply certain tools to measure the attitude of the subjects of both the groups. Then we collect the tool and we keep it for ourselves. Now, the experiment starts. We show certain films which explain the female abuse in different forms, in different places. Now, the movies are shown, the experiment is over, and now what we do is we again supply a tool to measure the attitude of the subjects of both the groups. Now, both the tools that are given to them earlier and also the experiment are analyzed and the results are drawn. This result is more reliable than the after only design, because the attitude of the subjects are measured even before applying the experimental variable, that is films on female abuse. Now, we can establish that the difference or no difference is due to showing of the film. Now, I explain to you two important types of experimental designs, the after only design and before after experimental design. Experimental design covers a few more types of experiments that are more elaborate and aim to determine the cause and the effect relationship more specifically and precisely. But before proceeding to explain other type of experimental designs, we should understand the basic outline of experiment once again. In experimental design, two groups are selected that do not differ from each other significantly. The experimental group is exposed to the assumed causal variable. The control group is not exposed to it. After the experiment is over, these two groups are compared in terms of the assumed effect. There are three types of evidences that are required for testing causal hypothesis. The first type is known as concomitant variation. The investigator could determine whether the assumed effect occurs more frequently among subjects who have exposed to the assumed cause than among those who have not been exposed to it. The second one is that y did not occur before x occurs. Since we are choosing two groups and apply a variable, we have to ascertain its effect on one group. This being the case, the differences in these two groups after exposure of one of them to x can be said to have decisively followed x. The third one, evidence of third type is concerned with ruling out other factors as the possible determining conditions of y, which may be occurred in several ways in an experiment. Such possible conditions are avoided by some kind of elimination. The first way is by eliminating factors that have occurred in the past. Second, by avoiding contemporaneous events other than the exposure to the experimental variable. The third one is maturational factor. Maturational or developmental changes should be avoided in the subjects of the experiment. And the last one is the influence of the measurement process itself. Different procedures have been evolved to eliminate each of the above type of factors as possible determining factor of y. One such measures is to select the two groups significantly matching with one another. Okay students, with this we have come to the end of the first part of experimental design. In this class I explained to you certain important factors relating to experimental design. First I explained to you what we understand by experimental variable, randomization and matching. Then I explained to you two important types of experimental design. One is after only experimental design and the second one is before after experimental design. In the next class I will explain to you few more important things about experimental design and also few more designs. Students, I have few questions to be answered by you. These are the questions. 1. What are the two types of methods employed to divide the subjects into two groups in experimental designs? 2. What is an experimental variable? Give examples. 3. Describe after only and before after experimental designs. We will meet in the next class. Bye.